So how do we do this? So mainly through weather forecasting and alerts, of course, that are shifted and fine-tuned towards fire weather. So of course, the National Weather Service and WeatherNet are both providing daily written forecasts to their clients. We're also providing alerts that are based off of radar interpretation, short-term watches and warnings that would be issued by the Weather Service. And then most importantly, we found was the deployment of our ESS or RWIS stations to these areas to collect actual samples and observations of what are going on. When it has come to burn scars, with our experience here, we've now dealt with several dozen since this initial project started in 2012, 2013. We find that portable weather stations are the most useful for us when it comes to burn scar kind of responses. Just to give you an example, the Department of Transportation here has 147 permanent stations, and then we have about half a dozen portable tripods and or trailers that we can move around to different areas. Based on our studies and talking with the Forest Service, we find that it typically takes 3 to 5 years for these burn scars to recover enough vegetation to no longer be a threat to our roadway and to be able to retain a lot of that mud and debris on the hills. So we do have that multi-agency coordination. In this case, we've expanded Pathfinder to be not only federal, state, but we've also included the Forest Service, the Geological Survey will often, USGS will come in and help us with these burn scar mapping areas. So we have a lot of different partners than you would just see with winter weather that had to be included when it came to burn scars and these flooding areas. The last thing I'll note on these weather stations is we've also included cameras on multiple of them. It really gives the forecaster a really good sense of what's going on in the area. If they can pan, tilt, zoom a camera around, look and see which areas of the burn scar might be raining, if they can see rain in the distance, if they can see standing water developing and things like that, just gives them a little bit of an added sense of situational awareness of what's going on out there. So as I mentioned, the big fire here in Utah was called the Sealy Fire that really got us going in the fire weather side of things. As you can see on this image on the far left of the screen, our State Route 31 ran right through the center left of our burn scar there. The first year that we had this burn scar in place, we had over 30 mudslides and debris flows reaching the road. There's kind of a sample of pictures here that you can see on your screen of some of the impacts that we were experiencing from these debris flows. During that first year, thankfully, of course, there was no loss of life, but we did have several vehicles and equipment destroyed or washed away. In this upper right picture, you can see one of our loaders was washed into the river and taken downstream a bit by some of the mud flows. And then in the lower right, you can see the response that summer, of course. We deployed one of our portable trailers on top of one of the nearby peaks of that area. We, of course, coordinated with the National Forest Service first to find out access to the area, permission, where the best areas to be would correspond with where we wanted to put that trailer. So we wanted to put it somewhere high on the ridge above the drainage for this area and also make sure, of course, it was out of harm's way so that we could collect as accurate a sample as possible. So kind of transitioning what we've done in Utah, some of our burn scars here, over to what we've done with California, especially in the last really basically 2020 all the way back to about 2018 when this started, so 3 years. So I have a map over here talking about some of the fires that were in the Yosemite National Park area. The two fires that I'm going to be talking about most specifically today are going to be Ferguson, which is the large fire there in the lower right, and then also Briceburg, which is much smaller. And I have a little bit more of a zoomed in map that we can show you guys in a minute here with some of the drainage basins that we were most concerned with in those areas. Talk about exactly how we wanted to tackle the problem with both those fires. So the weather forecast portion of these was going to be tackled with a variety of products. So the National Weather Service, of course, is issuing their products to the public on a daily basis, but they also set up a specific forecast for debris flows when it came to these fires. And I'll show you an example of that here in just a couple slides. And then Caltrans actually also asked WeatherNet to issue 2 times a day a forecast specific to the impacts to their roads and what their crews could expect as a result of any rainfall or debris flows that would be coming from these fires. So we deployed 2 weather stations. The first was in January 2019, so about a year and a half ago, almost 2 years now already, for the Ferguson fire. And then the Briceburg fire happened the following year, so we deployed a second weather station in 2020 in January as well. The Briceburg fire mirrors up right next to the Ferguson fire, but it was much smaller in nature. And then again, just to kind of reiterate the theme, as Pathfinder, this is another really good example of the federal, state, and private sectors working together. So you had Caltrans that really got a lot of this going there at the state level. And of course, the National Weather Service, specifically in this case, the Hanford office, was working very closely with both entities and WeatherNet as well, being the private portion of that collaboration. So the first fire that I want to talk about was Ferguson. So This Ferguson map was, of course, generated by the Forest Service and the USGS, and this map was the probability of the burn scars if they received approximately a quarter of an inch of rainfall rates over a 15-minute period. This is the probability of debris flow. So as you can see here, this black line is State Route 140 that's running right pretty much through the middle of the burn scar going into that Yosemite National Park area. And while the fire did cover a good portion of the road, especially there on the south flank as it went into the park, the area that they became most concerned with was some of these more severely burned areas over on the west flank of the fire. Those basins have seems to have a little bit of a hotter burn, a little bit of a more severe burn when it came to the removal of vegetation, and much more of a threat with the steepness of the road there to actually see some impacts to the road. So basically, they asked us to deploy the ESS or the station in that area so that we could collect our rainfall data in that area to represent this fire. And here's the Briceburg fire. And I'm going to go back just for a second so you can see this. But basically, right, this Feliciana Creek, right on the other side of this creek is going to be this Briceburg fire. So again, here's basically the same creek going right through this area here. And so this fire basically mirrored right up to where the Ferguson fire stopped over the hills just off to its east. So once again, a little bit of a smaller fire, but still kind of the same general area of concern here along State Route 140. So once again, they identified the basin that they were most concerned with, seeing any sort of a debris flow or mudslide reaching the road. We again placed our ESS, our weather station, right there at the top. You can see a little bit of a picture over here on the right of the station that we deployed. I'll also go back. So again, you guys can see the photo over here. We've got the anemometer, we have a temperature sensor. We also have a snow depth sensor over here on the side, as well as a rain bucket, which is actually behind the solar panels. It's a little bit harder. This station was a little bit smaller in nature since it was so close nearby. They did not want wind and temperature again just being a couple miles from the Ferguson fire. So in this case, we just put up a rain gauge and set up alerts for rain information. So how does it work now that we have these weather stations in place? So we've set up our stations to go ahead and alert the users of the group whenever they've received a quarter of an inch of rain over a 15-minute period. Our alerts go out to, of course, once again, the theme here, the federal, state, and private sector participants here. So we have Caltrans first that's getting alerts. This could be anything from their Caltrans regional manager all the way down to the crews that are responsible for maintaining the State Route 140. We also have the NWS Hanford office, the WeatherNet meteorologists, Mariposa County, and the Highway Patrol there for California are all involved with this. Of course, each one of these agencies is doing something a little bit different once they get that alert, but they make sure that we are getting everything out in a timely manner to all of them. These messages are sent out in a variety of different ways, depending on what the end user would like to see. We send out emails. We can send out a text message to the folks that may not be near their computer or notice that they have an email so that their phone is actively buzzing in their pocket and letting them know. We found this to be particularly critical for field crews that may be working on the road. We've had several rain events that have been in short succession where we may even be cleaning up the last debris flow and they're in an area of low cell reception for email reception, but they can get a text message. So we found that a lot of those crews that are out there working in the field really need that text message or direct phone call if they can get it where they're working. Another thing with the meteorologists are getting this alert, they often pick up the phone and make a direct call to a supervisor or operations staff that needs to know that information immediately, and then they can pass it on to their appropriate staff or highway patrol members, Mariposa County, etc. Of course, our goal working with the National Weather Service is for them to get timely flash flood warnings out, but also to not only help them get that information sooner, but verify any observations that they're making via radar, satellite, and their various other tools, estimated rainfall, things like that, with ground truth and verification that we can actually see. We can also then kind of collaborate a lot of that rainfall rate and data with what actually happened to the road and see, and for future events, how do we want to warn for this? How bad is this going to be based on what we've seen in the past? We can basically kind of judge what the actual impact is going to be in the road based on historical data instead of just kind of guessing. Work to try and keep these hillsides in place. The road closures that are necessary whenever one of these is triggered, it may be temporary just as a precaution. They may want to close it down, or they may actually have debris on the road where they have motorists that need to be helped out. If they're kind of trapped in an area that may be in danger for them, they know that they can respond to those areas right away with the highway patrol as well. again, Pathfinder coordination results in enhanced safety and hopefully maintenance crew safety as well as the public. So here's a couple quick examples of what these different forecasts are looking like, just to give you guys an idea. So over here on the right-hand side, we have the National Weather Service Ferguson and Bryceburg fire forecast that they're issuing. And we also have a text forecast from some of our WeatherNet forecasters. Again, very similar forecasts. We're hoping to mirror these up and go to our various users, whether it's the public or the state maintenance folks. We want to make sure that both have an opportunity to read a forecast that's really going to help them make it. So what did this look like in action? So you guys have seen how we kind of prepped for this and set it up. So on April 17th of this year, we had a heavy rainfall event. And so I put through here on the left a little bit of a timeline of exactly what happened that day. Of course, the day before, both entities, the Weather Service, WeatherNet, issued threats for slow-moving thunderstorms that would be possible the following day, And then we also wrote down here what type of alerts were sent. So you can see the National Weather Service went ahead and issued a flash flood warning, as well as calls being made by the WeatherNet staff ahead of the actual trigger in this particular case. So it was a very obvious event based on the radar that we were going to have a problem. And then very shortly after that, within about 15 to 20 minutes, we had our Ferguson ESS send us our first rainfall alert to all of our partners that we had received just over a third of an inch in a 15-minute period. And then we actually had a secondary alert from the Ferguson ESS just about 15 minutes later or so, letting us know that we had another trigger of just over a quarter of an inch in that 15-minute period. I've also showed over here on the right, I believe this was a tweet. It may have been a Facebook post. You'll have to excuse me, but the Caltrans District 10 went ahead and immediately issued the flash flood warning that the Weather Service had issued to their social media. They went ahead and put out that they were going to be closing Route 140 and that they were going to have a re-estimated opening time of 6 p.m. I can tell you, I believe this was pushed much later than that after the rainfall actually occurred and they were cleaning things up in that area. But it just kind of shows you an example from start to finish of all these agencies working together. I also mentioned to you guys earlier, the National Weather Service chat was a really good, medium for us to chat with each other. In this particular case, we had over here on the left side, the text that was sent back and forth between the meteorologists, just verifying exactly what had been seen. We both passed along the observations that we had seen for the last 15 minutes, the last hour. Both of us ensured each other that we were alerting the correct people. And in this case, everybody was on top of things, and we appreciate the partnership, and the RainGauge is a great tool. So again, in this case, all entities were, of course, on top of the storm, and it was a very slow-moving system that we saw coming for days in advance. But had there ever been a pop-up thunderstorm or perhaps an event that wasn't quite as widespread, hopefully these alerts and collaboration ensures that no entity is being caught off guard by what's going on. So again, this is an example of everybody working together, getting those instruments out there, getting forecasts out to the right people, and hopefully working as a team. So that's everything that I have on Pathfinder. I've got my contact information here. I'd be happy to answer any questions that you guys have. You're more than welcome to send those along to me anytime, and I will get back to you as soon as possible. With that being said, I guess we have a little bit of time, probably a minute or two, for questions if you guys have any now.
Well, we can give it just a minute, see if any questions come up here.
Absolutely. Yes, I will repost that in the chat so everybody has access.
Yeah, so it was asked to repost his contact information. We are recording this webinar as well, so that'll be available through the Alert User Group website here in the near future. All right, well, great. Thank you, Scott.
Of course. Thank you guys for having me.